put it. I have to leave it right here, Maggie, because
Okay.
I don't know if you want to move your seat. I think that's the best. So do I have everybody's quiz?
No, you don't have mine. I don't know.
Oh, I lost
I think it's just if it's coming in the.
Yeah, sounds good.
I just have one question.
Can you come to lab?
Yeah.
It is?
So should I just give it to you then?
Give it to me now.
Okay.
So what's today? The 9th?
Yeah.
Okay, so today we're going to learn about logs. And it's kind of one of my favorite things to teach
I found it.
because it's one of the things that people have the most trouble with. So I'd like to think that I can help you learn how to do this.
Here, right here, do you want my test?
Yes, please.
I have a
Come to lab period. If you have a question, come to lab period, please.
I do. I have lab on Mondays.
Um,
I have to move on Mondays.
so here's what I want you to understand. A log undoes an exponent. That's what you should write. This is 7.4 logs. So log undoes an exponent. Is that still okay for you guys?
Yep.
I think it might be better for the movie. Not really sure.
Movie?
Maybe not.
Hi, future people that are watching this.
So we call it it is an inverse operation. So undoes and inverse are kind of the same thing. And I'm going to give you some examples because I think this is why people get confused because this is a word. And in math, we normally use
Letters. Numbers.
it's an operation, symbols. So, for example, suppose I said, what operation is this? Multiplication. And how do I undo multiplication?
Division.
You divide. And how do we show division? How would I show that I want to undo math? Undo multiplication. I draw a line. That is a symbol. This symbol represents multiplication. This symbol represents division. Those are inverse operations. Multiplication and division, this looks like a minus, I'm going to do this, are inverse operations. To take things another step further, how would I undo this operation?
The square root.
The square root. So, this is a symbol, and someone tell me what this symbol,
Square root.
what does it mean? What question are you asking when you draw that symbol?
What two numbers?
What times
What times what? Itself.
What times itself? Yeah. So this literally means what times itself equals whatever it is we're looking for, right? What times itself. So we recognize that symbol. We can interpret that symbol to be what times itself. So, with that being said, we're going to learn the definition of log. And I'm going to tell you that if this is the only thing you memorize about log, It will help you answer all log questions. I'm pretty sure Lindley uses logs, and I know she undoes logs sort of the
Scientific.
yeah, and it's not, I think if you always use the definition, you can get it right. So here's, let me see how your book, I just want to be consistent with your book. Log base b of y equals x. So this says log base b of y equals x. So I'm going to write that. You read
What
it.
does base B mean?
Well, you're going to find that out in a minute. Log base b of y equals x. So you need to be able to read this.
So that B is a small.
Yeah, it's a subscript. So log base b, log and y and x are all on the same line. B is sort of a subscript.
Okay.
So here is the most fundamental thing that you should be able to do. And that is to rewrite this expression. So this means b to the x equals y. So this statement and this statement are literally equivalent statements. Do you understand why b now is a base?
Yeah.
Right, this is a base, this is an exponent. So b to the x equals y. That's how you need to interpret log. Just like we interpret this to say what times itself, this is telling us to say b to the x equals y. Or what do I need to raise b to get y? That's kind of what log is saying. All right? So if you memorize that, you are in great shape. So let's do some examples. Ready?
So
Ready?
Can I erase all this?
yes.
So tomorrow we're going to learn some properties of logs and how we use logs to undo exponents. But for now, we just want to learn to interpret that statement and rewrite it. So, for example, if I have, you guys could actually probably, so I'm going to ask you to rewrite in exponent form. Yeah. 2 to the
3
equals,
8.
right.
Does log show up on the calculator?
We'll get there. Good question. Does log show up on the calculator? Yeah, we're going to have to, now, and we'll talk about how we use the calculator. There's only 2 bases on the calculator, but we'll talk about that in a minute. And I kind of don't want to, so this is sort of the next step, but you guys can tell me what should go here. So what is this saying? 4
0.
to the 0 equals 1. Awesome. And so yes, if I were to rewrite this, 4 to the 0 equals 1. So if you can interpret a log, you're in awesome shape. So you will practice evaluating logs. Oh, here's a tricky one. Let's do this one actually. Let's just remind ourselves. My base is 1/4.
So it would be 4.
My exponent is -1, right? And what does a negative exponent tell you to do?
Flip it.
1
flip
over
it.
1/4.
Yeah, well, or if it's a fraction, just flip it. It's easier to think about, like if it was, 6 to the -1, I would say 1/6. But if I had 2/3 to the -1, I would flip it, right? If it's already in fraction form, I would just flip it. Yep. So yeah, that's just being able to rewrite a log. And if you can rewrite a log,
You can solve it.
Can't you just write that as 4? The first equals 4.
our instructions are to rewrite the log as an exponent. So my base is 1/4. My exponent is -1. 1/4 to -1 equals 4. I'm just rewriting this in exponent form.
It's like still as an exponent, it's just in simpler form.
I don't understand what you want.
Like I still put an exponent up there.
Oh, you put a 1 up here?
Yeah, I just put 4 to the first equals 4, so it still had an exponent. It just is in simpler form. I just already flipped it.
Oh.
Yeah.
Yeah, well, in terms of interpreting this, you should have this. Because there's your base, there's your exponent, there's your answer. So if you want to show me that you understand how to rewrite a log, that's what you would do. Just rewriting it. Okay. So let's see if we can evaluate some logarithms. If you can do this, then you should be able to evaluate. Now here's what I do. If they give me this, so this is an expression. Remember, we evaluate expressions or simplify expressions. It's not an equation, but I like to change it to an equation. They want to know what is this equal to. So I sort of finish it. I put a little equals x. Does that work for you guys? Well, so what? So what? How would you rewrite this then?
4 to the x equals
4
64.
to the x equals 64. So that's the first step. So, well, the first step was really to kind of add this equals what? 4 to the what equals 64. And then what's the answer?
4 times 4 is 64.
4 to the 4th? I think, yeah. So x equals 4. Yep. So log
4
base
to the 4th
4.
is 256.
Oh, it's not 4 then. It's 3.
4 to the third.
Is it 3? 4 to
Yeah.
the 3rd? So log base 4 of 64 is 3 because 4 cubed is 64. There's another one.
And then
No, 4 times 4 is 16. 16 times 4 is
How about this? Log base 2 of 32, and again I'm going to say equals x. So the question is really what? 2 to the
x
equals 32. So again, remember me saying that instead of a symbol, we actually have a word. But what does this word say? This word is saying, what do I need to raise 2 to get 32? And what's the answer?
5.
5. Yep. Because if I raise 2 to the 5th, I get 32. So again, always think about reinterpreting this. What does this mean? 2 to the 5th equals 32.
Is this? Oh no, I'm not even gonna ask that question because I'm gonna move on. I saved myself.
You saved yourself? All right. I don't mind questions, but if you think it's irrelevant or you already answered the question, then this one's a little trickier.
Ooh.
So give people a chance to think about this, boys and girls, too. So don't shout out too soon.
Where's the equal x?
I didn't. So I'm reminding you that they don't give that to you. So you gotta
Right.
write it. So go ahead. I like to put the equals x there. Yes, Charlotte.
Wouldn't it be?
Well, tell me how I would rewrite it first.
So you do 36x
36 to the x
to the x
equals
six,
6.
and then x would equal 1/2.
Awesome. Yeah, because what do I need to do to 36?
Square it.
Square
Root.
root it. Yeah. And how do I square root that? I raise it to the 1/2. Yeah. So log base 36 of 6 is 1/2 because 36 to the 1/2 equals 6.
What does that? When you type 1/2, is it a calculator? Does it not work? Because or should it still work?
If you put in parentheses, it should still work.
Not put it in parentheses.
If you don't put in parentheses, remember, order of operations says to do exponents first. So if you type this into the calculator, it's going to do 36 to the 1 and get 36.
Divided.
And then it's going to divide by 2 and give you 18. But if you want it to raise it to the 1/2. Now, again, the newer operating systems throw you up into the exponent
So
and
you
they,
don't have to do that.
yeah. And so you have to tell it when you're done with the exponent. But it's a good thing to know and remind yourself order of operations. Okay, so let me do one more sort of tricky one.
Ooh.
And don't say anything just yet. I'd like to try to help people along a little bit. It says log base 1/5 of 125. And what does Viv like to do? Add the equals x. So then I can rewrite it as 1/5 to the x equals 125.
Oh, I don't think I got it right now. Okay, I'll put it on my paper.
First of all, what do I want to do to 1/5 to even start thinking about 125? I'm going to do what to it?
Let the
I want to flip it. So I know my x has to be
negative.
negative. So as soon as I flip it, instead of dealing with a 1/5, now I'm dealing with
5/1.
5. And so what would I need to raise 5 to? That took care of the 1/5. What would I need to raise 5 to get 125?
3.
3. Yeah. Awesome.
I was right.
Good.
Don't tell yourself, Brianna.
So log of 1/5 of 125 is negative 3x. I got to flip my 1/5, becomes 5, then I cube it, it becomes 125. Nice.
Good teamwork, everyone.
All right. Okay. So that's good. We can do that. I'm going to erase.
I log your wrist.
Can I erase everything?
Yeah.
Oh, what was that?
I don't know.
Our calculator, so sometimes you have to evaluate a log with a calculator. So
P.
evaluate logs with calculator.
Oh, I got it.
Jeanette, you have that written down?
Yes.
Okay. Our calculators only have 2 bases. I should say calculators store only 2 bases. Because how many different bases are there? There's an infinite number. 2 to the what? 12 to the what? 17 to the what? 154 to the what? You could go on and on and on and on. So the calculator stored only 2 bases. Plain old log is really log base 10. So we don't write it. We don't write the base 10. If you don't see a base, it's base 10.
Wait, why?
Because that's just how it is.
So log is the same thing as log.
If you just see log without a base, it's log base 10. So, for example, if I asked you log 100, I sometimes might tell myself, okay, I know it's not here, but I know that it's base 10. So the question is what? 10 to the
100.
X.
10 to the
x equals 100. So what
2.
would that? 2. Yep.
5.
So plain old log means base 10. But what if I asked you to do this? Log of 75. That question really, this is saying 10 to the what is 75. Do you guys know that off the top of your heads?
7.5. No.
You don't know. It's less than 2, right? And more than 1. So now you can go to your calculators and find the log button. It's in the first column.
1.
And just type log 75, and what do you get?
1.87.
That makes sense, right? We know it's going to be less than 2. 1.87, is that what you said?
What would be 1.88?
Oh, 1.88. Okay. So that's log base 10. We just use log, we don't put the 10 in there.
Enter.
That's one of the bases.
I found catalog.
Log is right there.
Oh.
2 is ln, and you guys are going to love this because it's French. It stands for, and what do people, what would you want to say? I already told you it's ln. People always say
In.
in. It is not in, it's a lowercase l and a lowercase n, and it is logarithmic natural. It's the natural log. So it's not an I, it's an L, because L stands for log. The natural log. And what was the number that we used when things were growing in nature?
Is that an I
E.
or an L? LN?
I just went over that, Jeanette.
I'm sorry.
Why is it an LN and not an IN?
Logarithmic
'Cause
natural.
Yeah, it stands for L, logarithmic natural, natural log. So actually, I don't say it in en français. I just say, I read this natural log.
Oh.
But right in French, we do the adjective after the noun. But I read it natural log. Just like, Green Mountains. Vermont. Mont Vert. Okay, so natural log. So yes, our base is E. That's Euler's number. So if I ask you this, ln of 20, that question is really E to the what is 20? Does anyone know?
No.
No. So you just type it into your calculator. So you find the ln button.
2.926. 3.
2.96.
2.96. It's almost 3. Yeah, because we all know that 2, well, it's almost 3.
Oh,
3 cubed is 27.
It's 3.
It's free.
Oh, you were right.
It's 3
I
exactly?
was right.
Did I really come up with the 3 exactly?
Yeah, it was
Crazy.
2.996.
Okay.
This
5.
one's up. So it goes up to 10.
yeah.
So it should be that.
So ln is base E. And our calculator only stores those 2. Later we'll learn how those 2 logs will help us do any base. Okay? Our calculator needs to store 2 of them. All right, let me.
Did not work.
2.3.
We kind of did one like this. Let me see. I have you guys stop at 31. What time does this class end?
35.
It ends at 35?
Yeah.
Okay. I'm going to show you this. This is my least favorite thing about logs. I feel like you don't need to know this. So I'm going to throw it up here. If you guys, if it makes sense to you, great. If not, it's fine. You can memorize it. I can explain it to you, but my guess, based on my experience, I'm going to say that it's just better to memorize it. And you have to think that a log undoes an exponent, and an exponent undoes a log. If you keep those two things in mind.
What?
Just write it.
Okay.
Just like multiplication undoes division and division undoes multiplication. This is a little less familiar to us, but a log undoes an exponent and an exponent undoes a log. So I'm going to try to convince you guys why this works, and then you're just going to memorize the answer. So, let's just look at this part of it. Log base 7 of x equals question mark, right?
Yeah.
So what does this mean? 7
7
to
question
the
mark.
what
Oh.
equals
X.
x. So 7, let me do this actually. Let me call it a y.
Oh,
So-
that's a good idea.
Let me call that y. 7 to the y equals x. Yes? Does that work for everybody?
Yeah.
So I just said this is equal to y. So I'm going to come back up here and replace that. Log base 7 of x equals y. So instead of log base 7 of x, I'm going to call that y. Is that okay? I'm just substituting.
Yes.
Yeah.
I'm substituting y for log base 7 of x
Oh.
in this. But what did I just say down here?
7
to the y equals
X.
So what does this equal?
X.
X. So what does this equal then?
X.
Just equals x.
So
Because this log base 7, this log undid this exponent, and my answer just becomes x. These guys undo each other, and I get x.
Is every answer going to be X whenever we do that?
So for example, if I said 9 to the log base 9 of x, what's the answer?
X.
X. So you just memorize it. But it works, because this is really saying, what do I need to raise 7 to get x? Well, if I raise 7 to that number, I'm going to get
X.
x. Yeah. It's hard for you guys. I mean, I've been teaching math for a long time, so it's easier for me to really conceptualize that. But basically, this log undoes this exponent, and the answer is
Will
that.
it ever be like 7 log
Yeah.
base 8?
No, then you couldn't do it. Good question. Has to be the same base.
So what do you do if it's the same base? I mean, if it's not the same base.
You
then
wouldn't
it's
have a
question.
problem like that.
Okay.
And I think, for example, Lindley sort of teaches you how to do this to undo a log, but what I tell people to do is use the definition. We all know the definition. 10 to the this equals that. If you use a definition, it's way easier than this because I feel like this is sort of, it's like math magic in a way.
Is that a Q?
Let me give you another example that's similar to this, but not, okay, so for example, this is the alternate of that. That's 9, log base 9 of x equals x. So here, so if I say log base 5 of 5 to the x, did I write that right? Yeah. So again, what would this be saying? 5 to the what equals 5 to the x. So what's your answer?
X.
X.
Wait, explain that again.
It's X.
So- So when I didn't have this, we all know that this means 5 to the what equals 5 to the x.
It's X.
So it's got to be x. But again, this log kind of undoes that
Oh,
exponent.
it makes sense.
Just
now.
like this log undid this. So these guys cancel each other out. I'm left with x. These guys kind of cancel each other out. I'm left with x. But again, I don't use that inverse operation. I use the definition of logs, which I think if you learn, that's what I'm saying. If you learn that, and I'll never forget taking a student to the Math 2 SAT, or picking a student up from the Math 2 SAT. And he got out and he said, "What does log mean again?" And so really, your best bet is just remember something like this, that this means 2 to the what equals 32. And we know the answer to that, it's
X. Oh, no.
5. Yeah. So if you can rewrite a problem like this, then you can figure it out. Even if you had to use your calculator for trial and error, you could do it, right? 2 to the what equals 32. So if you remember the fundamental definition of logs, you're in great shape. I have 5 more minutes. So I hope we have some time to investigate this later because it's really important. But I'm just going to introduce you to what a log function looks like as a graph.
Why is there graphing to everything? Yeah, that's true.
Graph, simplify, evaluate graph, simplify, solve. Those are the things we do in Algebra 2. So let's go back to this idea of, suppose I have y equals b to the x. What does that look like? If it's growth, it looks like this. Yes?
Yes.
So since a log is the inverse, it looks like this. This has a horizontal asymptote. This has a vertical asymptote. So it's taking this graph and flipping it over the line y equals x.
Wait, what would we call this? Evaluate logs with graphs.
Oh, this is just graphs of logs.
This side.
We can make a television show of this.
So it inverts it. So this is, this would be y equals log base b of x. And so, I had a worksheet. I don't have time to give it to you, but actually, I think I'm gonna give you the worksheet too. It should go pretty quickly. I just want you to think about this for a minute. If we think about has anybody ever tried to make a scale model of the universe or the planets?
Nope.
Yes.
You know how the rocky planets are kind of close to the sun and then the big gaseous planets are really far from the sun?
Yes.
So it's really hard to put them on the same scale. So if I'm trying to graph something and one of my numbers is 10 and one of my numbers is 10,000, how do you get that on the same graph?
Those squiggly lines.
Oh, you have like
That's such a
10
good
on
option.
each line.
Well, this is really 10 to the 1, and this is really 10 to the
10, 12, 13,
Oh,
10 to the 100.
1,000,
10 to the 10.
8,000.
10 to the
Oh.
4.
10 to the 4, right? And 100 would be 10 to the
10
Two.
10 to the
2, and 1,000 would be 10 to the 3. So I could literally graph these as 1, 2, 3, 4. But this is really 10. This is 100. That's 1,000, and that's
Why can't
10,000.
we use the.
So it's a way.
Oh.
Yeah, but if you do that, it doesn't work. So this is, I'm just kind of describing to you, why would I want to use a logarithmic graph? And it helps me put really big numbers on the same scale. Otherwise, how do you put 10 and 10,000 on the same scale? It's very difficult. And I'll show you an example of that tomorrow. So, for example, do you guys, who here, is anyone in here taking chemistry?
I am.
And you've done pH, right?
Yes.
The pH is a logarithmic scale because the pH is the hydrogen concentrations, the hydrogen ion concentrations. So you can have like 10 to the 1 hydrogen ions, or you could have like 10 to the 7 hydrogen ions. So this thing could be jam-packed with hydrogen ions, and this thing could just have a few. So we have to use a logarithmic scale. So before you guys go, here's what I want you to do. I would,
I thought we have the.
yeah, 1 through 31 odd. Okay, you can just do those. That's fine. Just do those. And we'll pick this up tomorrow.
Okay.